You are welcome to the third study session. I hope you really enjoyed the first study session where we talk about the physical quantities, and the second study session where we talk about motion. In this session, we'll be looking at dynamics. After this session, you should be able to explain the concept of force, understand Newton's law of motion, apply the concept of Newton's universal law of gravitation, apply the concept of work, energy, and power, and thereafter you should be able to state conservation laws. Dynamics. Dynamics is the second part of mechanics in physics that study the motion of body and the cause of the motion. In other words, a force can cause an object with mass to change its velocity, which at first may be at rest or moving with constant velocity to accelerate. Force can also be described by simple concepts such as push or pull. A force has both magnitude and direction. Thus, a force is a vector quantity, and it can be expressed as F equal to Fa, where F is the force, M is the mass, and A is the acceleration. Let's look at first law of motion. A body will continue in a state of rest or constant velocity unless an external force acts upon it. What this is telling us is this: a body will remain in a state, or else it is being pulled or pushed. And this law is what we refer to as law of inertia. Second law of motion. The rate of change of momentum is directly proportional to the force applied, and the momentum change is in the direction of the applied force. Mathematically, that can be expressed as NV. The momentum can be expressed as NV. So the general equation can be expressed as N into initial velocity minus final velocity over time taken. Newton's third law of motion. To every action, there is equal and opposite reaction. Let's look at law of universal gravitation. Every object in the universe attracts every other object with a force directed along the line of center for the two objects that is proportional to the product of their masses and inversely proportional to the square of the separation between the two objects. And that can be represented as F subscript G equal to capital G multiplied by the first mass M1 multiplied by the second mass over R squared. R is the distance of separation between the two objects, where M1 and M2 are the masses. Work. Work is a phenomenon that is done when a force moves through a distance. So when a force acts on a body and causes it to change its position, we say work has been done. Energy. The energy of an object or a body is the ability or capacity of the object to do work. The energy quantity of an object can be in various forms. One, we have heat energy, we have electrical energy, mechanical energy, chemical energy, sound energy, light energy, and atomic energy. Power. Power Power is the time rate at which energy is used, or the rate at which work is done. It can easily be calculated by dividing work done by time or multiplying force by velocity in mechanical process. By derivation, the unit of power will be joule per second. However, a conventional unit which is equal to joule per second is used as the unit of power, which is watts. 1 watt is equal to 1 joule per second. Larger unit can be expressed in kilowatts, in megawatts, and so on and so forth. Conservation laws. Conservation laws, also called laws of conservation. In physics, there are several principles that postulate that certain physical properties do not change in the course of time within a closed physical system. They are law of conservation of energy. This law implies that energy can neither be created nor destroyed, although it can be changed from one form to another. Mechanical energy can be changed to electrical energy. Chemical energy can also be changed to electrical energy. Then the energy possessed by virtue of position of motion, which we call kinetic energy, can as well be converted to mechanical energy. In an isolated system, the sum of all forms of energy therefore remain constant. So it can neither be created nor destroyed. We have law of conservation of linear momentum. This law expresses the fact that a body or system of bodies in motion retains its total momentum, the product of mass and vector velocity, unless an external force is applied to it. In an isolated system, such as the universe, there are no external forces, so momentum is always conserved. Because momentum is conserved, its components in any direction will be conserved. Law of conservation of angular momentum of rotating bodies. Angular momentum is a vector quantity whose conservation expresses the law that a body or a system that is rotating continues to rotate at the same rate unless a twisting force called a torque is applied to it. The angular momentum of each bit of matter consists of the product of its mass, its distance from the axis of rotation, and the component of the velocity perpendicular to the line from the axis. And let's look at the law of conservation of matter. Postulate that matter can be neither created nor destroyed. That is, processes that change the physical or chemical properties of substance within a closed system, such as conservation of solid to a gas, leave the total mass unchanged. When you conserve a solid to a gas, the mass still remains the same. Actually, mass is not a conserved quantity except in nuclear reactions, where the conservation of residual mass into other form of mass, energy is so small that to a higher degree of precision, residual mass may be thought of as conserved quantity. Let's look at friction. Friction is a resistive force which acts at the surface of separation of two bodies in contact and tend to oppose the motion of one over the other. Take for instance, as you are walking on the floor, there is a friction between your palm and the floor. Loss of friction. The excessive work of Leonardo da Vinci in 1452 to 1419 and Charles Coulomb yield the following laws of friction. Frictional forces between two surfaces. is independent of the area of the surface in contact. Opposes motion between the surface. Depends on the nature of the surface. Is independent of relative velocity between the surface. Is proportional to normal reaction. Statics or limiting frictional force is the type when the body is just about to move over another surface. That is where you talk about static or limiting frictional force. Thus, if F suffix x represents the static frictional force, then the static frictional force can be written as Fx equal to mu suffix x multiplied by n. Suppose a body is sliding over another with uniform velocity. The frictional force called into play is called dynamic frictional force, represented as F suffix d, and is given as mu n. Let's look at angle of friction. Angle of friction is defined as the angle which the resultant or the total reaction makes with the normal reaction. If the normal reaction N and the frictional force is compounded into a single force. Momentum. The momentum represented by P of a body is the product of the mass of the body and its velocity. That is N times P. The momentum of a body of mass N and velocity is given as that. The unit is kg meter per second, kilogram meter per second. Impulse. Impulse is defined as the product of the force and the time during which it acts, provided the force is constant. Collision. Let's look at what we mean by collision. One of the most important applications of conservation of momentum law occurs in the theory of collision. Collision simply means the coming together of two bodies at different velocities, which could result into scattering or conservation of the body. There are two types of collisions to which we give the names elastic and inelastic collisions. In an elastic collision, both momentum and kinetic energy are conserved. That is, no energy is lost from the system. An inelastic collision is one in which only momentum is conserved, while kinetic energy is not conserved. E.g., some energy is lost to friction, crumpled feathers, or such. Thank you for listening.